42 is kind of an interesting lesson. Here we're finding the distance from a point to a line. It's not a typical geometry topic that you would think of when it comes to your polygons and perimeters and area and all that good stuff. But it's just kind of a general concept like, okay, what would the distance be between a point and a line? And even better yet, what would be the shortest distance between a point and a line? So that's what we're taking a look at today. So here we have a line. We also have our point of location. And the question is, what's the shortest distance between those two? So, if we were just doing an experiment and looking at some of the different options we had, we could maybe draw in this line here and say, oh, that's going to be the shortest line. But I think some of us would argue and say, no, I think I could get a little bit closer. I could maybe draw in this one. But even furthermore, somebody might say, you know what? I think if I took a straight edge and made a straight line going from the point to the line and also used a protractor to ensure that I created a 90-degree angle, I think that would be the shortest one. And long story short, you would be right. So to kind of get to the nuts and bolts of this lesson, the shortest distance between a point and a line is going to be the line that's created at a 45-degree angle to that line. And again, we could use some arguments as to, okay, the further away we get from 90 degrees, the longer the distance it's going to be, like that black line there. So with this idea of the shortest distance between a point and a line being the perpendicular angle, we start to create some of these theorems. So theorem 42-1, through a line and a point not on a line, there exists exactly one perpendicular line to the given line. Once again, through a line and a point not on a line, there exists exactly one perpendicular line. So if we go back to this example, notice there was only one line that was the shortest distance, and only one line that could be drawn at a perpendicular or 90-degree angle to that line, and that was the line in red. Again, assuming that I took the protractor out, got it down to the exact amount, and created that 90 degrees. There's only one that could be created. If I were to say, okay, we got the red angle and then we also got the blue angle at 90 degrees, well, we would know that's not true. Okay, we've created two of them, and that's what's not the case here with theorem 42-1. It's saying there is exactly one line perpendicular to it. And then for 42-2, kind of brings this all together for us. The perpendicular segment from a point to a line is the shortest segment from the point to the line. So not only is there just one line that's going to be perpendicular through that point, but once we establish that one unique line, that line is going to be the shortest one. Or that line segment, I guess. Let's go ahead and move on to example number 2. Pause the video if you need to finish copying those down. But we want to find the distance from point 64 to the line y equals 1. 64. Let's go ahead and sketch this. 1, 2, 3, 4, 5, and 6, and 4. 1, 2, 4. There's our point. And now the line equals 1. You know, I think it's important that we continue to review y equals a certain value is always going to be a horizontal line. And a horizontal line going through that value. So we understand that, hey, that is a horizontal line going through 1. If it was x is equal to a certain amount, then it would be a vertical line. So I think once we sketch this thing, I think we can start to use a little logic and reasoning to come up with this distance right here. 1, 2, 3 units away. So there's our distance of 3. Example number 3, it's given y is equal to 2x plus 1 and the point 32. So let's start with the point 32. 1, 2, 3, 1, 2. And then if we draw on the line, there's my y-intercept of 1, up 2 over 1, up 2 over 1, up 2 over 1, and downward in the same direction. There we go. once again, we want to find the point on the black line to where it's closest to S. And there's maybe a better line being drawn. So, how do we need to go about doing this? A couple of things come into play. Number one, we talked about it in the previous example that the shortest distance is always going to create that perpendicular angle. There it is, the shortest being the red. So using that idea, I need to come up with a line that is perpendicular to the given line. If we go back to the given line, our slope was 2. To come up with a line that's going to be perpendicular to it, we need to go back to our rules of perpendicular slopes and use the opposite reciprocal. So that right there just established what type of a slope we're going to have with this newly created segment. Now the good news is we don't have to worry about a y-intercept because we actually already have a point that this thing's going to go through. It's this point right here at 3, 2. They told us it has to go through that point. So because we have a point and we know what the slope's going to be, we can just go ahead and draw in the slope off of this point. So from this point, I'm going to go down 1, right 2. Down 1, right 2. And obviously to find that distance or to find that point, I need to go in the opposite direction. So up 1 over 2, up 1 over 2. Here is the segment that I needed to do that. And one more time, it says to find the point on the line that is closest to that. Well, we fell right on that line, or right on that point, there at 1, 3. So make sure you get this one in your notes. The key is finding the perpendicular slope off of the given line. The slope originally was 2. The perpendicular slope has to be -1/2. And then we draw that -1/2 slope off of that given point. We're finishing with a couple of theorems to add to your notes. First one being 42-3. Perpendicular segment from a point to a plane is the shortest segment from the point to the plane. And then we'll go ahead and talk about theorem 42-4. If two lines are parallel, then the points on one line are equidistant from the other line. Alright, so we're kind of expanding a little bit. Let's go back to the third one here, the first one on your screen. The perpendicular segment from a point to a plane is the shortest segment from the point to the plane. So what that means is we're using the same concept of going from a line to a point, and the shortest distance being the perpendicular one. Well, now instead of a line, imagine that this line is now the whiteboard. So the shortest distance from a point in space to the whiteboard would be a perpendicular segment. That would also result in the shortest distance, or the shortest segment, from the point to the plane. And last but not least, two lines are parallel, or if two lines are parallel, then all the points on one line are equidistant from the other line. So just a quick visual, two lines, they're parallel, now it's official. What they're saying is, okay, these 2 points, as long as it's perpendicular, are going to be equidistant. So again, if they're perpendicular, if they're the shortest segments that we can create, then the red line would be the same length as the green line. If you got any questions, please let me know.